This classwork begins with using a zero exponent. Basically, the way I use a zero exponent is anything that applies to it becomes 1. So here, 0 applies to the whole thing, or in other words, x, so I can just write the answer 1. In this case, that 0 exponent only applies to the y. It doesn't apply to the 6. So if I look at this as multiplication of 6 times y to the 0, I can see that is really 6 times something I can replace by 1, because anything to the 0th power is 1. That's how I get a final answer of just 6. For part C, it's a little different. Unlike this 6 that didn't have that power of 0 being applied to it, this 4 is inside the parentheses with the x. So this whole expression 4x is all being taken to the 0th power. That means the entire thing is just equal to 1. So make sure you see the distinction between this situation where the whole thing equals 1 and this situation where just the thing being taken to the 0th power equals 1 and then needs to be multiplied by the coefficient. When we look at negative exponents, remember that what we want to do is take it to the other side of the fraction and make it positive. So really, if we want to have something that starts as 3 to the negative 2, we should put 1 over 3 to the positive 2. Since I can do 3 to the positive 2 or 3 squared, I should really call this 1 divided by 9. In part B here, we have a negative exponent on bottom. Really, we want to bring that to the top as a positive exponent. So this would just be 4 to the first over 1. But anything over 1 is itself. Anything to the first power is itself. So really, I just want to write this as a simple 4. When I get x to the negative 2, same idea as what I did in part A. I do 1 over x to the positive 2. The only difference here is since we don't know what x is, we can't go any further with the problem. That's as far as I can go, and I would leave it as 1 over x to the second power. Same idea here. X is negative exponent negative 8 on bottom. Let's bring it to the top and make it x to the positive 8th. Really, anything divided by 1 is just itself, so this is just x to the positive 8th. You absolutely don't need to do this step in between. I'm just trying to show you why it's the same as what we've done above. When I get the negative first power applied to the whole fraction, all that really means is flip the fraction. It's another way of saying take the reciprocal. So I'm going to show you step by step why that is. Basically, this negative 1 can be seen as 5 being taken to the negative 1 power over 6 being taken to the negative 1 power. If I want to rewrite that as positive powers, the 6 comes to the top as 6 to the first. The 5 goes to the bottom as 5 to the first. Since we don't really need powers of first power, it really just means the same thing if I write it without it. I want to just write this as 6 over 5. So if we look at what really happened, we had the original fraction 5 over 6. All that happened by applying the negative first power to it is it flipped, and we got its reciprocal 6 over 5. X to the third, y to the negative 5th means x to the third doesn't have to move at all. It's now understood on top of a fraction over 1, so it's going to stay on top of that fraction. Whereas y to the negative 5th does have to move. Since it's got a negative exponent, we want to take it to the other side of the fraction, namely the bottom, and keep the same exponent but make it positive. For writing numbers in scientific notation, our goal is to see where the decimal point is and how many we have to move it to get it behind the first number. So when I say the first number, really first non-zero number. Here the decimal point would start behind the 5,000. If I want to move it so it's behind the 5, I'd have to move it 1, 2, 3 places. That's why in scientific notation this would be 5.0 times, and I'm going to use a dot for the times symbol just so we're not getting it confused with x's. So times 10 to the power of 1, 2, 3, because we had to move it 3 to the left from where it originally started. Remember, if we start with a big number that we're trying to put in scientific notation, big number meaning something bigger than 1, that's when I have a positive exponent. As opposed to here, when we start with a small number, small being relative to 1, if this is smaller than 1, it's going to have a negative exponent in scientific notation. So we know that we want to get the first thing behind that 4, so we're going to get 4.0. To move it, we're going to have to move it 1, 2, 3, 4, 5. Again, I want to make sure this exponent's negative because I started with something small and I had to move the decimal place to the right. So in scientific notation, this would be 4.0 times 10 to the negative fifth. Here, I want to start out by saying it's going to become 6.78. So 6 is the first number in sequence, but I need to keep these two with it. If I move the decimal point that starts here, I'd have to move it 1, 2, 3, 4, 5, 6 to get it behind this 6. So that's why this is times 10 to the power of 6. 1, 2, 3, 4, 5, 6. When we go in the other direction, helpful hint is your calculator a lot of times can do it for you, or if you put this in, it'll tell you literally what the answer is. That said, there's going to be times where there's too many digits to fit on your calculator, so you do want to understand how to go backwards using moving of the decimal, but don't be afraid to use your calculator to put in something like this and see what it says to check an answer. So 1.2 times 10 to the second really means 1.2 times 100. What I'm doing here is I'm moving 2 decimal places because there's 2 zeros here, so I have to move this 1, 2 spots. So 1.2 becomes 1 spot, 2 spots, put a 0 in any empty spaces, 120. 5.9 times 10 to the negative 4. My trick for negatives that I think makes things much easier is just include that many zeros before your first number and make sure that one of them is the 0 in front of the decimal place. So if I write 1 0 in front of the decimal place, I got 3 more to go. 1, 2, 3. I now have 4 zeros, including the one in front of the decimal place. I can place my numbers, 5, 9. The other way of seeing this is I could start at 5.9 and I could move the decimal place 4 times. 1, 2, 3, 4. Here's the new place that the decimal is, and I fill in with zeros. Notice that these are slightly different because I didn't place my 0 in front of the decimal point, even though it's there and understood. So if you place the 0 in front of the decimal point when you're doing a negative exponent and trying to put in standard notation, then you can count that one and make sure you include as many total zeros as you have in the negative exponent. Then start with the number. When I do 9.1 times 10 to the 6th, I'm going to start at 9.1. I'm going to move 1, 2, 3, 4, 5, 6. Here's my new decimal. I have to fill in 1, 2, 3 zeros, 1, 2 more zeros, and that 1 can stay. If I want to rewrite this in standard form, I probably want commas. So really, I have 3 zeros at the back. I'm going to need a comma to say that's thousands after that. Then I have 0, 0, 1, 0, 0, 1. Then I need another comma before the 9. So it's really 9,100,000 that we have when we have 9.1 times 10 to the 6th.